All right, so let's try this again. You guys ready? Are you actually ready? So, class.
Yes.
Thank you. Okay, derivative logarithmic functions. So we keep plugging along about we keep adding a new type of problem that we're doing derivatives of. So now we're coming up with logarithms. Logarithms is it's the inverse of exponential functions. So you could turn an exponential function into a logarithm or vice versa. Because everything in math has something, an operation that will undo it. So those things will undo each other. Opposite of multiplication, to undo a multiplication, I would have to divide. To undo an addition, I have to subtract. Undo a square? Square root. So here's the rule here. Derivative logarithm function. Now, both of these are actually the same. They're the same thing. But when you look at ln, isn't ln just log base e? ln is just log base e. So if I use that information here, and I say that log, so y is equal to, here, let me get a new one here. Is that the same notation? Yeah, same notation. Okay, so then in terms of y prime is equal to 1 over x ln of a. But ln, so if I say that ln y equals ln of x, that's the same as saying y equals log base e of x. Are you guys okay with this? Yes, no, maybe? Never seen it before in your life. That's where these things come from. So it's just log base e. Now, I'm going to use the same thing right here. So this is going to be y prime is equal to 1 over x ln of e. Can anyone tell me what ln e is? 1. It's just 1. So it's basically saying times 1. So y prime is equal to 1 over x times 1, which is the same as saying just 1 over x. So again, they're both the same. It's just right there, ln e goes away.
So these tests are designed to fit in with
Oh, it's you. What?
these tests are designed to fit in with the textbook.
Yeah.
We didn't do the textbook, we do the worksheet.
The worksheets are from the textbook.
Yeah, but they have like the definition on
They are. It's the same definitions that are from the book too.
like, you're asking to fill in the blank that's on the textbook, not on the worksheet.
Okay. It's just the vocabulary.
What the hell? There's no vocab.
Anyway. All right.
Just a concept.
Yes.
I did not get that.
You did not get what?
How you put L and E in there.
Okay. So see this right here?
Yeah.
Do they mean the same thing?
Yeah.
Yes. You're okay with that, right? Now, this is from the formula that they gave me, right? So I rewrote it as log, because ln is just log base e, right? Okay, ln is log base e.
What about the x?
The x is what it's of. That's like of right here. Or it's that same x.
Oh, okay.
That same x. And then from here, the derivative, even the derivative of log gives me an ln.
Yeah.
The derivative, this is from my formula that they gave me. They gave me this. So I get that ln no matter what. Okay, so that's ln of e, whatever my base is, right? Ln of whatever my base is here. And the base here is e. So I'm using this, so 1 over x. You're okay with the 1 over x? Okay, then on the bottom, I should have ln of whatever my base is. In this case, my base is a, but over here, my base is e. And then ln of e, those things equals 1. Okay. All right, let's try some of these problems. What rule applies to this first one here? Chain. So chain rule. So I'm going to start by going. What should I do, soldier boy? You. I'm trying. U equals what? Ln x. U prime is 1 over x. What'd you say, Blade?
You didn't start doing that until she later said
I haven't started yet. Okay, so.
I'm like too quiet, but I don't want to be loud.
Oh, okay, it's Monday. So are you saying it's not something I do? You can go check my videos for the last 10 years. I've been doing you ever since Soldier Boy came out.
Really?
Yeah. Go way back to the old videos, and when 2 Chainz was a rapper, they thought it was the coolest thing ever when they got 2 Chainz.
Were you like a rapper too?
Yes. Okay. Worked in the mall at Christmas time.
Oh, okay. You're rapping like Christmas jingles?
No, presents.
That was a stupid.
Why? Because you didn't get it?
I did not get it.
Okay, even better. All right, so this is going to give me u squared. So y prime is equal to 2u times u prime. Right? Okay, so it's going to be y prime is equal to 2 ln of x times 1 over x. And no, those will not cancel out, because that x is a part of this. One half log x. Does this require any chains? Nope. It requires a little bit of memory.
Just like expand it?
No, a little bit of memory. What's your a value in this problem?
Or
10. 10. Log with no base is base 10. Log with no base is base 10. So this is y prime is equal to 1/2 times 1 over x ln of 10. That 1/2 is just the coefficient, just the number out front. So I can combine it as let's see this next one. Ln x plus ln y equals 2x. What type of problem do we have here? Implicit, very good. It is implicit. So since I have a y in my equation, so every time I take the derivative of something that's not x, I need to include a dy dx. So derivative ln x, 1 over x, plus derivative ln y, 1 over y, dy dx is equal to 2.
Don't you just say equal to 0?
Huh?
Don't you just set it equal to 0?
No, because the derivative of 2x isn't 0.
Yeah. So if it was just 2, on a lot of our implicit that we did, this was a constant number over here. And so since it's a 2x, the derivative of that is 2. But we normally would just have a constant of 2 and the derivative would be 0. But we would set it equal to 0 if we're trying to factor or do anything else out of it. But this is just the problem as it is. So now I need to get the dy dx by itself. Yes?
I was interested. We needed to solve for dy dx.
Yes, we solve for dy dx here. I'm going to start by subtracting 1 over x.
Do we have to show the word?
On problems that say show your work.
Okay.
Right here, how do I undo that 1 over y? Multiply both sides by y.
What was the example you gave in one of the other notes where you didn't set it equal to 0 and then?
That was when we're solving and we actually had to factor,
Okay.
but it was equal to 2. And so it said instead of actually having it, we didn't have it equal to 0 to do zero product rule, it gave us a value for the y, and I had to factor from there.
So it is expensive that only to factor.
Yeah, factor. Yeah, zero product rule is what I'm factoring in. Because anything times 0 is 0. So if I want to make a statement true, I use that. All right, next one is y equals log base 2 x cubed. Yeah. Do I have a chain here?
Yes.
Yes, I do.
Oh,
Because of that x cubed right there, right?
but isn't that with the x?
It is with the x. That's inside with the x, so that's an x cubed. Because all these other problems that I've been doing are just x's by themselves. And so I need to treat it as if that one there is going to be my u. So it would be u. Then I rewrite the problem. Y equals alright, my derivative, use that formula. Y equals, someone help me out.
1 over x.
Over what?
1 over 2 ln of
W, right?
ln.
Ln. I heard it, what? 2, very good.
Times 3x squared.
Or my u problem.
For the bottom, can it also just be 2 ln u? Like.
No. Because that 2 has to go inside the ln.
Oh, okay.
Has to go there. Alright, and put it all back. Y, well these are all y prime, sorry. 1 over x cubed ln of 2 times 3x squared. And I put it over 1 to try to simplify it, to try and show what we could do with this. What can I do? Can I do some canceling? I could cancel that x squared, right?
Isn't it next cube?
Huh?
Next cube.
X
Oh, so then you
x
just do next
squared.
one.
Yeah. So 2 of these cancel 2 of those. Yes, no, maybe? Alright, that's those. So, basically, same thing that we just did. This is the notation in Leibniz form for having to do a chain rule. So, yeah, chain rule in Leibniz form.
When you say the difference was between undefined and defined,
I almost heard you.
what you say the difference was between does not define and
Undefined and does not exist. So existing has to do with real or non-real. Undefined would be dividing by zeros. So I'm going to leave off right here. I want you guys, homework, I want you to start on those. Start those problems right now. And make sure everyone likes, share, and subscribe.